Good morning, Ledworks engineers, and welcome to another exciting episode of Weekend Workshop, where we discuss the ongoing development of Ledworks Game Engine 5. Today we'll be talking about the beginnings of 5.1, which is going to be a very interesting update. Now that we have version 5 out, we've got a better idea of how people are using it and what it needs to do. And 5.1 is just going to take that knowledge and make some adjustments. Before we get into that, some stickers are appearing in the wild um, from the game tournament. Some stickers. Some people are posting stickers, showing what they put their stickers on. I think this looks very nice. Um, yeah, I've never been to South America, but it looks a lot like the Balkans from this picture. So if you see a motorcycle, this one or another one, driving around your town with Leadwork stickers, it means that that person is a very special person who entered the game tournament and got the stickers. So glad to see that I sent those a couple weeks ago, and it's fun for me to see like how you guys use them. Also, some concepts for some plush toys that came out. This is the pillow with the Leadworks icon on it, and then this little character. I think he's sort of becoming the mascot. Maybe we'll use him in some kind of demo sometime. He's kind of a cute little robot. I don't know if we can. Yeah, actually, I did look up. They do have some plushies that have like a battery, and the eyes will light up like that. So it is actually possible to produce something like that. Um, kind of funny.
That would also look great in the engine, the texture, the furry texture, all the shades.
Yeah, it does look pretty good. I wonder if we could do that in the renderer. That's Yeah, the lighting on that is really interesting, actually. Um, okay, so one of the goals in Leadworks 5.1 is to move the lighting into a deferred step. Currently, we're using a forward clustered plus approach. I wanted to try. id Software is using this. I think one of the Splinter Cell games is doing it. So it's not. I mean, it is a legitimate technique that's being used, but I think deferred lighting might give us better results. Um, because one of the goals is to like basically make the pixel shaders more lightweight, and so I'm no stranger to deferred rendering. Leadworks usage of this goes back to 2008. That's when I implemented it. Leadworks was the first indie game engine to use deferred rendering. There were two games that came out before I did this, and they were Stalker and Killzone 2. Um, but Leadworks was the first that came out. Leadworks was the first engine, like general purpose engine, to do it. And this is a just a um, kind of a paper I wrote. It's not published anywhere, but it gets cited a lot. It's just uploaded on our website. Just talking about our implementation of deferred rendering when we started. So this is a technique I'm very well familiar with. I didn't invent it, but I was just the first to start using it. Um, this is what I'm thinking for the G buffer layout. We have one texture for color, one texture for octahedral normals. You can pack that into the X and Y channels with using just 8 bits per channel, and then use the second two channels for roughness and metalness. Use the third texture for emission, RGB, and then put occlusion in the alpha channel. Have one texture that an integer texture for like material and entity flags, and then also a value for the decal layers, which controls which decals appear on which surfaces. And then finally, we can have an optional final texture for this would store the motion coordinates for motion blur in X and Y in two channels. And then in two other channels, it would store the terrain blend color and the terrain the terrain color blend and the terrain normal blend. So for mesh terrain blending, this could be used to indicate like how much of the terrain color and normal should override that pixel, and then the terrain mesh blending would be applied to it in a post processing step, and that would be super efficient. I think that's probably the best way to handle that. So yeah, I'll add a link to this document if you want to read it yourself. Actually, I'll paste that in the chat here, and then I'll also paste it in the comments in the description in YouTube.
So this is just how the data is being handled internally by the engine. This is nothing we have to worry about, correct?
Right.
All right.
So that's that. Pretty straightforward stuff. It's not super difficult. Okay, now I want to talk about culling. LUDWORKS 5, it implements an asynchronous culling system, and the thread structure basically looks like this. Each one of these circles is a thread, or it's the GPU, and so data goes. This is where all your code lives in the game thread, and data goes to the rendering thread, and a little bit of data comes back from the rendering thread, and then the rendering thread offloads the culling onto a separate thread, and that sends data back to the rendering thread, and then the rendering thread sends data one way to the GPU, and this is where the actual rendering takes place. So this is how it works now. Well, the benefit of that is when you do the culling out here, the culling is effectively zero cost. So it calculates all the visibility in this thread, and then when it's done, it sends that visibility set back to the rendering thread, and the renderer just starts using it. So that's extremely efficient. The problems are that you can have objects popping into view because there's some latency here, because the renderer is rendering something from like a few milliseconds ago. So it doesn't have to slow down, but the data it has can be a little bit like slightly outdated by a couple of milliseconds or so. So as a result of that, you can have objects popping into view if you rotate the camera really fast. You can minimize this with the camera set swept culling feature, and this like adds some like prediction to the current camera rotation speed and velocity, and it's pretty good. Like it almost completely eliminates the problem. It's not perfect, but it's pretty good. Another problem is that if you have a light that's dormant, like its shadow isn't being updated, and then it moves in the game, and then so like an object that's cast in a shadow, it moves. It's just sitting there, and the light is not being refreshed, and then that object moves, and the renderer, it doesn't know that light has been updated yet, so it doesn't have an updated visibility set for that light. So it has to tell the culling thread, hey, this light has been updated. Can you make me a visibility set for it? And the culling thread says, okay, yeah, sure, no problem, bro. Just give me a second. And then it sends it back to the rendering thread after it's done. And so, but by then, like the rendering thread has already rendered one frame. So as a result of that, like if a light is not being updated, and then something happens that triggers it to be updated, you can have a one frame delay where the shadow hasn't been updated yet. And the worst case of this is when you can actually see this in the first person shooter example. When you open the swinging door, the first swinging door in the level, I guess it's the only one, but when you open that door in the level, depending on the timing, on the exact moment you do it, like there can be a shadow can appear on, like the door's own shadow can appear on it, like the first frame that it moves, and then And then what happens is the renderer tells the culling thread that that light needs to also be updated, and the culling thread starts sending back a visibility set for that light, and then it starts updating the light. So you have this gives you better performance, but the cost is latency, and that's how we see that come out. Both objects occasionally popping into view, although I don't think the problem is super bad, especially because of especially when this feature is enabled. I think it's okay. And then you also can have a 1 frame delay before shadows get redrawn. And then finally, the memory management for this is a lot more complex because, like, let's say an object gets deleted here. Well, a message gets sent to the rendering thread that says to delete the corresponding object here, and then the rendering thread sends a message to the culling thread that says delete the corresponding object here, and then the culling thread sends a message back to the rendering thread saying, okay, this object has been deleted. Now you can delete any GPU resources that it's using. So it is a little bit more complicated. So, with everything, there's a trade-off. The benefit of that is the culling is basically zero cost, and that's one of the reasons why LedWorks 5 performs so extremely well with large numbers of objects. I wanted to see what would happen if I moved the culling thread, I moved all the culling code into the rendering thread, and instead of using an octtree data structure, like stepping through an octtree, I wanted to just try like a brute force approach, and just do like very, very optimized C++ code in a loop, and just loop through every object in the world and evaluate it as quickly as possible. And I wanted to see what would happen if I just did that and just made really optimized C++ code, because very optimized C++ code can run like, it almost feels like it's running like as fast as a shader, like as a compute shader, because it's just insanely fast. So I wanted to try that, and I have some interesting results for you. So what I did is, this is just using super optimized C++ code that evaluates every single object every frame. So it'll go. I mean, if you have 10,000 entities in the world, it will iterate through that vector of 10,000 entities. It just does it really, really fast. But it turns out C++ can do that very, very quickly. There's no octree or data optimizations or any kind of like hierarchy, scene graph, anything like that, because I think that's actually slower than just looping through the objects. Now, up to a certain point, like if we were dealing with like millions of entities, then that could be different. However, I think we've made the decision that this engine is for small and medium-sized games, and by medium-size I mean 16 square kilometers or so, which is the size of the biggest maps in the original Crysis game. So that's actually like pretty huge. That's what I call medium. And when we define our scope like that, then we can start making better decisions about, because we know we don't have to worry about things beyond that. We can start making the decisions that optimize the engine for that scope, which is quite large still. So instead of focusing on like clever tricks or some kind of scene hierarchy structure, it's just brute force, fast, optimized C++. The results are pretty good. Let me show you what I got. Oh, before we continue, like, this is what I expect in a large scene. I would expect to see like a large combination indoor-outdoor scene. So I'm thinking something like Stalker, where you have, or Crysis, where you have like buildings across a terrain, and and each building is probably full of like furniture and small objects that have a probably have a pretty probably have like a pretty limited view range, since you can't see them when you're in outside the building anyways. They would probably disappear from view at a pretty like a short medium distance. I would expect to see about 3,000 entities in the scene. I think is a good number. The most we've seen like in the zone scene that we did, which is pretty old, but it does have a lot of objects. It uses a lot of entities in the scene beyond just vegetation.
My question:
Yeah.
is it possible that you could switch between the cooling methods? For example, when you have like a planetary scale game, then you will probably have a distance current. In normal games, you would have more like obstacle cooling. But in space, there is no obstacles. They're just very far, so we have probably distance cooling.
Yes, but that means twice the bug reports. So I prefer to just like find one solution that works best for the ways for what we're doing. As a general rule. So let's see. Let's say we have 3,000 entities in the scene. That doesn't count like plants and trees and rocks, because that that kind of stuff gets handled in the vegetation system, and that's where you can have millions of objects. But like entities, like models, 3D models placed in the scene. Let's say there's 3,000 in the scene, and let's say at any given time there's 1,000 on screen. So either they're behind the camera or out of the camera's view, or they have a limited view range and they're culled by distance. So 1,000 entities on screen, and let's combine that with, let's say 2 million vegetation instances, like total trees, rocks, plants combined. Let's say that's a reasonable number. Let's say 75% of Steam users have a 60 hertz refresh rate, but let's say we're aiming at 144 hertz refresh rate, and that gives us it's like 6.94 milliseconds for the frame time. Like the frame needs to be rendered within about 7 milliseconds if you're rendering at 144 hertz. So this is what I'm expecting on a big scene to consist of. So I did some tests with 10,000 instance boxes all on screen at the same time. The culling time was between 0 to 1 milliseconds, and the resulting frames per second was 619. With 10,000 boxes, they're instanced and they're all behind the camera. Culling time was like close to 0 milliseconds, and the frames per second was 2,500, which is less than the maximum frame rate. But I mean, they do have these. It still has to iterate through those 10,000 instances, but it's just done very, very fast. When I had 1,000 instance boxes on screen, which is more along the lines of what we said we were expecting, like normal usage to be, the culling time was close to 0 milliseconds, and the frames per second was over 3,000. And then when I had 4,000 unique boxes, like each is a different mesh, the culling time was 0 milliseconds, but the frames per second was quite a lot lower, because it's rendering 4,000 separate meshes. I think processing these. Actually, I'm not sure like what the bottleneck is here. That's not bad. That's still like 5 times faster than both LeadWorks 4 and Unity. Actually, that's 150 times faster than Unity. Actually, I take that back. That is 150 times faster than Unity. But that's something I'm going to look into a little bit more, actually. I don't have anything else to say about that. But, I mean, these numbers are... This is looking pretty good. I mean, it's like 0... I mean, so what we're doing is we're taking this code, and instead of running it asynchronously on a separate thread, we're running it here right before the frame is drawn. So if the frame is drawn here, let's say, this isn't a great visual for that, but like the frame is drawn, we're performing the culling right before the frame is drawn. So it's always up to date. It's always, there's no latency. It's always immediate. And it's only adding like, I mean, with 10,000 objects, it's not even adding 1 millisecond of culling time. And I think 10,000, having 10,000 entities in a game, I think is probably not a realistic use case scenario. Having 1,000 entities on screen is a realistic use case scenario on the high end. And then, maybe if you have a directional light, maybe those are being culled 3 times in the directional light shadow stages, like the shadow partitions, because it has to render the scene several times. But still, I mean, these numbers are very, very low. I mean, most of this is too low to even measure in milliseconds because it's less than a millisecond. So it's like, if we do the culling here, it does add some overhead in the rendering thread, but it's not very much. And as long as the rendering thread is still running faster than the screen refresh rate, then everything's good. So the only problem here is if you run like some of the stress tests that we have, where you have like 30,000 objects. This approach would produce a slower frame rate when VSync is disabled, but it would still run at real-time speeds, and it would still be like 5 to 10 times faster than both LEDWorks 4 and Unity. So it seems like we kind of have... It seems like I almost like went too far with this, and I just optimized the hell out of the CPU rendering speed, but at the same time, like the pixel shaders could use some more love and care. They could use some more attention. So if I did this and then you combine that with more optimized, with more lightweight pixel shaders, switching to deferred lighting is one of the ways that we do that. Then the real result, like your games would actually, the real result you would see in your games is they would run faster in 5.1. So the downside is some of the stress tests would appear to run slower when VSync is enabled. Like you're not going to get like 3,000 frames per second. The benefits are it's still fast enough to support like the ways the engine is realistically going to be used. It eliminates the latency. So that compromise we have to make of adding latency to the culling results, we can eliminate that. And the performance is still good. The visibility set is always up to date, so you don't ever, it's impossible to have that object pop in. It'll never happen. You'll never have any shadow update latency because the culling is always calculated right before the frame is rendered. And it also simplifies the memory management and the internal structure in the engine. This is how it is now. This is how it would be if I performed the culling in the rendering thread with this approach. It is a lot simpler that way. Now, if we want to take it further, a next step might be to perform all culling in a compute shader. We already use this for the vegetation system. If you want to render millions of objects, we have a system specifically designed for that, for plants and trees and rocks. That's the vegetation system, and it does use a compute shader right now for culling, and it's extremely efficient, and that can handle millions of objects. So we know this approach works. If we applied that if we applied that to the culling for the entire engine, you would have zero cost culling with zero latency. You would also have no information available on how many objects were actually drawn, because that would all just be calculated on the GPU and the renderer wouldn't know. And it would produce faster performance under these extreme stress tests, but I don't think you'd really see any difference under normal usage. I mean, this is what I'm seeing right now with the CPU handling the culling in the rendering thread right before a frame is drawn. This is pretty darn good. There's a little, I mean, it adds a little, I mean, if it adds 2 milliseconds if it adds 2 milliseconds of processing time to the rendering thread, then your maximum frame rate would be 500 frames per second. But I mean, as long as it keeps up with the screen refresh rate, like, that's all that really matters. And this is adding very little processing time. I mean, this seems like this is better than I thought it would be, actually. It seems extremely efficient. So in order to eliminate that latency in the culling results, it seems like this might be a good approach to take. And then if we want to go harder in the future, like, using a compute shader for everything might be a good solution, but it looks to me like it's already fast enough to where even if I was using a compute shader, you wouldn't really see any difference. I mean, the only difference here is you do have to start with this approach. You do have to start thinking about. Right now, you don't really have to consider like how many draw calls you have. So we don't even, like, when a scene is loaded, I don't even bother merging the brushes into bigger chunks, because there's no need to. If we do this, then I might want to make the scene loader just automatically collapse brushes into big chunks so that fewer objects are being drawn. But still, I mean, this seems like fast enough for anything that we would realistically want to use the engine for.
I got two questions. One, what hardware are you doing the benchmarks on? And two, if you were to collapse the brush, would you provide us a function to check if a model is a collapsed brush, like there was in LedWorks 4?
I'm running on like a 10-year-old computer. The GPU doesn't really matter in this case because we're testing the CPU speed, but the right. CPU on this is like a 7700K Intel.
All right, so it's like, yeah, so 7th gen. Okay, so you are like using like the shittiest hardware you can find to test this.
I don't think it's that shitty.
Well, old, like
yeah, this is not. Yeah. So it's like that would introduce some overhead in the rendering thread. I'm just saying, like, it's very little. It's like a lot less than, it's still like 5 or 10 times faster than what LedWorks 4 and Unity do. And in order to, I mean, like, it's like we can have the rendering overhead, we can have the rendering speed be like 20 times faster and make some compromises to achieve that. Or we can have the rendering thread be 5 to 10 times faster without making any of those compromises. And right now, like, nobody's bottlenecked on the rendering thread speed. What people are hitting a bottleneck on is the pixel shaders. So if we make the pixel shaders more lightweight, then this overall just gives us better results, and as a result, like, your games will run faster in 5.1. I mean, the only scenario where this would be worse would be if you're making a game where you have like 30,000 asteroids just sitting there in space. Yeah, in that case, that's the point where you would where a GP where a compute using a compute shader for all culling would be an improvement. But I mean, under normal usage, like you don't use that many entities. I mean, a big scene will only have a few thousand, and it'll only have maybe 1,000 on screen at any given time.
Right. I think, like in my scenarios, my entity count will be more on brushes than like props or.
Yeah, in our game, I think we'll probably only have like if we merge the brushes, I think we'll only have like probably about we'll probably have less than 500 entities in any given scene, I would guess.
Right. And there's going to be like a function to check if something was a collapsed brush in the API, correct?
Yeah, I would probably create like a new entity type that's like BSP tree or something like that.
Gotcha. Or maybe I know like a way to get a BSP to not collapse in Levelworks 4 was to attach an empty script to it. So like triggers can still work if you use the brush planes to detect like
Yeah.
something's in the brush.
I would probably just use I would check to see if any script is attached, and I would also check to see if the brush is marked as static. If there's no script and the brush is marked as static, then I would collapse it.
And it's going to be marked as static by default.
Yeah, they are right now.
All right. Okay.
Yeah, it's just it would perform worse under like really extreme stress test of like 30,000 objects. I mean, because right now like it'll run at 1,200 frames per second if you have 30 with the current design. It'll run at 1,200 frames per second with 30,000 boxes. So this does introduce some overhead, but are we making? I mean, are we making games or are we making a box simulation to see how many boxes you can draw?
Asteroid Simulator.
Yeah, the asteroids. If anybody was making that, that's one situation where a GPU. That's where I would start looking into compute shaders. But I mean, it's only in these really really extreme examples that you would see a difference. It seems like, I mean, it's so fast. If it adds like a couple of milliseconds of overhead to the rendering thread, we can still run everything we want at 144 hertz, and the structure of the engine becomes a lot simpler. Those problems with objects popping in or lights not being immediately updated when something moves, those go away. So it just seems like we're making a lot of trade-offs right now for something that we're not really using. And we can just eliminate those trade-offs and get a better result this way, it seems to me.
What happens when you have a point light and an object is not lighted? It's in the dark. Will it be cooled also?
You mean when it's within the shadow's range, but it's in with it when
No,
it's
I mean
with,
it's in a light range. So let's say you see it completely black, and you have only one point light.
right.
And will it only render those which are in the point lights area, because else they would be completely black?
Well, yeah. I mean, it only draws what's within that lights area for sure.
Okay.
That actually raises one good question, and that's I want to do more testing to see like I mean, point lights are relatively expensive to update, so you don't want to have too many of them updating anyways.
Mm.
But
I
I
was
want I
also
want to
thinking that if it doesn't work with point lights, maybe I could have something like distance fog, like black fog in the distance. And if that doesn't work, then maybe just have like a manual update of the cooling distance based on the fog range or
wait.
the
What do
light
you mean
range.
doesn't work?
I mean, if it doesn't cool automatically,
Well, yeah, it'll. I mean, the
three.
lights are cameras. They're considered like internally to the engine. A
Okay.
light is a
Ah,
camera.
okay. Oh, yeah, yeah. I remember that. Yeah. Okay.
So when the calling is a little bit different, but when it's calling a all the objects for a point light, it just finds all the objects a within the point light's bounding box, and then it considers those to be visible.
Yeah, right. Okay, the bounding box. That's the
Yeah,
key answer here.
that raises a good
Also,
that raises a
oh,
good
go ahead.
question where like I might actually want rather than iterating through every single object in the scene for small lights, I might actually want to have like a simple optimization structure for those.
What
But don't you
about
need Octave for bounding boxes? Isn't that a normal way
No,
to
that's
handle
what
that?
I'm saying is like it's faster like for just a camera. It seems like it's faster just to use brute force. I just right now I'm like for the camera I'm iterating through every single object in the scene, and it's crazy fast.
what about like spotlights? Because I know there's a problem where I like the mapper would want like to get a lot much light as possible into the scene, so they would make like the spotlight really big. Is optimizations for that or tools or techniques to adjust that coming in 5.1 or later?
Well, one thing I see a lot is one thing I see you doing, and in some other games, I see people using extremely wide angle spotlights um, to light a room. So it's kind of like, uh, let's see
I
if I
think
can.
yeah, because the issue is like because you want like a certain like angle, like cone, but I want it like to project across the room, and I guess like I'm not happy like how much the light is bouncing because of that. And in the source engine, like you can make your spotlights as big as you want, and everything is pre-calculated, so you didn't really have to care how big it was.
What a lot of artists do drives me crazy, but they'll do so it's like here's your room, here's your light. They'll do something
Yeah,
like this.
yeah, we want to make sure the entire room is lit.
And so if any object out here moves, it affects the whole
Yes.
spotlight. And also like
So
it
it's,
has to even though it's confined within this room, like it has to render everything that's way out here. So my idea is to just introduce another radius value where it just cuts it off like right here, and it basically becomes a cylinder. So it's a cone up here, and then it's like a cone on top of a cylinder, and then that would confine that volume within. You could use that to confine the volume within the room, and then you wouldn't have these huge, enormous things that take up the entire map.
yeah, that would be very useful, but is that going to be a 5.1 feature or a later, something later?
No one can know the future.
No, understandable. It's just because you're you're doing everything in the same thread now, and a lot of people do that, including myself. So
I
I
will
guess we'll
say
see.
the answer is definitely maybe.
Okay.
Definitely maybe.
Hey, I try to make my spotlights as small as possible. It just doesn't give me the results I want.
You do not try. You make them as big
I
as
do
you
try.
make them huge.
No, I do try. It's just I like
You
how
always
they
use
look
like
when they're really
5 degree
It looks so good.
it performs so terribly when you do that. Okay, that would be a good solution though. Okay. And then, if we need to in the future, like a compute shader, using a compute shader for all culling could be a great solution because that's zero cost and no latency. I just don't know if you would really see any difference. I mean, this is already crazy fast, like 1 millisecond, not even 1 millisecond culling time for 10,000 objects. It seems like this is good enough for for everything except stress tests. It seems like this is good enough, and it would simplify. It would eliminate some problems and make life simpler. So, okay. We have 8 days left of the Kickstarter campaign for the FPS weapons pack, the new FPS weapons pack for Leadworks 5. This includes about 5 clothing variations on the hands. So you've got like both military and sort of like survival kind of clothing. It includes the source files in FBX and TGA format. Models are around 35,000 polygons each. You've got grenade launcher, you've got a crossbow. All the guns here are listed. I'll have a link in the description on YouTube. You also have some melee weapons, and you have some weird things you don't really think about, like a syringe for first aid. You've got a grenade you can throw, a lantern, a flashlight, a candle, a knife. Like you have both a hatchet and then you have this, the thing that looks more like a fireman's axe. But I need to pay the artist in order to use these. So if you would like to see this become available, we have a Kickstarter campaign up right now. There's 8 days left, I think. 8 days to go, and if you get this in Kickstarter, like what you actually receive is a Steam key for the DLC when it gets published, and that will be so the DLC will be on your Steam account just as if you had bought it from Steam. You're not just getting sent a zip file; like it'll actually be a DLC that will be permanently on your account, so you'll always have those items available, just as if you had bought it on Steam. Okay, so before we continue, I will read out. This is where I read out the names of everyone who has recently given us a thumbs up on Steam since the release of Leadworks 5. They include Primar Rus, Aztec Shaman, Ananto, Pridrito, Nijek999, WW, Two Cats Yelling, Comunista, Safado, Reap Blue, Mapache 3D, Tapani, Neoxa, Kema 401, Alkivir, Arkenstone, Garlic Waffle 979, Matarine, Dumage, and your Rembo. The last two are entries from the, and Garlic Waffle as well, are entries from the most recent Winter Games tournament, as well as Reap Blue. I think that's everybody. So thank you very much. If you could add your review on Steam, it really makes a big difference. I really, really appreciate it. We need more reviews on Steam. And if you want to subscribe to the YouTube channel, we almost have 4,000 subscribers. So if you subscribe, it'll just push us up towards 4,000. It looks like we'll hit that pretty soon. But Steam reviews, please. Thank you. All right. Do we have any questions, comments, hopes, dreams?
And you promised me transparency will still work after this.
Yeah.
Okay.
Yeah, good question actually. How about this transparent glass, which has like a mosaic, like a church mosaic, red, green, blue glass? Would it cost the light, like a colored light?
Oh,
That
like
used,
the pure light
that,
demo he did
that
like
used,
10
used to
years ago.
work in older LEDs, I think LEDVest 3 or something.
There's two ways to do that. Actually, like one way is to include a color texture along with the shadow render, and that's what I was doing I did that in that demo. That's how I did that. So that's one way to do it, and another. I mean, you can't do it. You can. That has to be something I program, but it is possible. The other way that might actually work is the technique where you make transparent shadows by discarding every other pixel in the shadow map, and then because of the shadows, when the shadow is rendered, like it does a lot of different lookups on the shadow map to sort of blur it. So if you discard every other pixel, that actually does a pretty good job of doing transparent shadows. Um, I guess you would still need to render the color texture in either case, but so I guess that doesn't. I guess that's kind of irrelevant, actually. So I take that back. But yeah, it would have to render to a color. It would have to be set up to render to a color texture. I mean, it is possible to do. Maybe I will add that as a feature.
And I assume there's no global illumination feature yet coming.
Well, the global illumination. I mean, the for dynamic object. Currently, we use the environment probe, the volumetric environment probes, which do a very nice job, especially for. They're really great for dynamic objects. And then what I'd like to do in 5.2 is implement a light mapper, but it's a special one. It doesn't include the direct lighting in it. It just includes it's just a light mapper that just calculates the indirect lighting alone by itself, like isolated, and then use that for static surfaces and combine it with the real-time lighting we have now, and that would improve the static surfaces, instead of using the volumetric environment probes, they would have some light mapping applied to them, like baked global illumination, and that would give like more nuance and more detail. It's something we want in our game because we have a lot of very light surfaces. We have a lot of white walls, so that's where that kind of thing is really going to show up a lot. So that's something I want to do in 5.2, and we need it in our game because I think it'll look really, really good.
And what's up with that? Many games claim to have ray tracing, but I don't think it's real ray tracing. It's some kind of wannabe or fake ray tracing. What is it?
Well,
You probably heard of it.
do you mean hardware like GPU ray tracing?
Yeah, something like that. I don't really know what's going on there, but
Well, no,
I've
that's
heard
I mean
that
that's
everybody's hyping it.
it's been around for since the 2000
Yeah.
series.
Yeah.
The problem is it sucks.
Okay.
And not just on the low. Well, first of all, like
So it's very low resolution ray tracing, I assume.
well, I mean, there's two problems. One is that GPUs and memory have gotten way too expensive, and so as a result of that, by my calculation, about 55% of Steam users have a GeForce 1080 or less, or something worse than that. That's about 55% of the market. And the people who are upgrading, most of them are upgrading to like 3060s, 4060s. That's about another 30% of the market, and only about 15% of the market have something like a 4070 or a 3070 or the equivalent AMD card. So
Okay, so it's a hardware feature of high-end cards.
yes, but that's one issue, and then the other issue is even if you have like even if you have a high end card, it still sucks. Um, the the only way they got it to work in sort of real time is by using a lot of they spread the task out over several frames, and it uses ray tracing accumulation. Um, and so as a result of that, like any moving objects tend to leave trails behind them. Even on high end hardware, this happens. Um, so it just sucks. I mean, it's like
Yeah,
you're
okay.
maxing out like a an expensive graphics card, and the lighting still looks worse than.
Yeah. So I guess it's just another hype which is not ready yet. Like Vulkan was also kind of hype, was not really ready. Maybe it's getting ready sometime, but so I think it's good what Leglex has done now to choosing a robust platform like OpenGL and then making stable games which actually look good and work fast.
Yeah, there's just been a lot of confusion. Um, I'm gonna paste a couple of videos.
I was just wondering about Vulkan because today I saw a new video, but I don't know what's going on there. Is Vulkan now better than it was before, or? But you say it when you switch from Vulkan to OpenGL, you say it performance was not much worse or even better, and sometimes.
Oh, it got faster on AMD cards, but I mean Vulkan's
Yeah.
basically dead, dude. It's just for writing
Okay.
DirectX drivers for Linux.
Okay. Yeah. I was
I
just
mean,
wondering, it's back now, or yeah.
it sucks, and it's the thing is like okay, like um, working on getting 3D World Studio to run on today's computers was kind of interesting because back when I wrote it, everybody was like, "Oh, you should be using DirectX 8. DirectX 8 is so cool. Microsoft is behind it. OpenGL sucks." And then 20 years later, um, the game SCP Containment Breach, like DirectX 7 is basically non-functional. It barely, like the drivers are really bad for it. 3D World Studio, because it was written in OpenGL, it worked perfectly with no changes. The people who are pushing DirectX 12 and the Vulkan approach right now, I know that like they have a lot of power in the industry and they're using that to ram it through, even though a lot of people hate it. But those people are going to retire. I mean,
Yeah.
they're eventually going to retire, and they're going to leave a mountain. They're going to leave a mountain of technical debt behind that nobody wants to maintain.
Yeah, and I also heard modern graphics cards have a hardware problem. They are designed to work the wrong way. There was some problem with the textures. They are such horrible quality. And the reason was many games and game studios wanted that. And now the hardware industry has bent to their will and made actually things worse than they were before. I don't know if you've heard about this issue. There was something about texture quality.
So the DirectX 12 ray tracing performance is 50% faster. Okay, wake me up. It has to be like 100 times faster for it to actually run in real time. Let me show you what I mean.
I think that's something to do with the 4K displays and stuff like that. It has kind of like a somehow render them good looking on a 4K on 8K display, which is of course nonsense in that sense.
I mean, this is a YouTube video in a YouTube video being transmitted over Discord, but you can probably see how horrible this is.
Yeah.
It looks so bad.
Actually, it looks really bad. It looks like a JPEG low quality compression.
Yeah, so it's not real time. They can't do real time ray tracing. That's not real time. They have to spread it out over like the course of like 1.5 seconds. They have to spread it out over like 100 frames. That's why I'm saying literally like ray tracing GPUs would have to be about 100 times faster than they are now to actually be able to do real ray tracing. and that's on good cards, which 85 or so percent of the uh, of the player base has no access to. I heard Doom Dark Ages actually sold like less than 1 million copies.
because of the hardware issue.
I don't know. Oh,
Yeah,
90%.
like
Okay, well, 90%. Okay. Okay, now it needs to be. It doesn't need to be. If they doubled the speed almost, then it no longer needs to be 100 times faster. Now GPUs just have to be 50 times faster than they are now. So when they make a GPU that's 50 times faster than a 5090 with the latest update to DirectX 12 and it costs $300, then we will do ray tracing.
I do have a question for like the distant future. I'm noticing a lot of more approachable computers are just 10-year-old computers with a phone chip in them. I understand you don't want to do mobile chips, but if they start jamming these into like machines, would you reconsider?
Wait, are you talking about MacBooks?
Well, that's something that came out today. They pretty much took the M1, that's the computer I have right now. They just
Chromebooks,
took that.
Chromebooks also.
They just took that, stuck an A18 in it, and resold it for $600, which is more approachable than one their mainline computers than two any other computer.
Is it a
Recently.
Windows? Is it a Windows machine or a Mac?
Well, Apple, well, it's Apple, so it's Macintosh, but Windows is doing the same thing. They're taking the Snapdragon processors and just jamming it into laptops.
What percentage of Steam users have ARM chips?
Well, none, but I'm just saying, like, in the future, it may be more of a thing. Like, nothing you have to do right now. It's just something you want to, like, consider in the future. Because I really think that more consumer-grade hardware is going to be ARM in the future.
I've seen so many hype cycles that are like, oh, you better watch out. This is bound to happen in the future. It's right around the corner. My attitude now is just like, I mean, everybody said that, iPads were gonna wipe out the PC. We were all gonna be using tablets. We were all gonna be working on tablets, and I mean that went on. That was just so obnoxious for the longest time. And it's like we're still all using, uh, x64 processors. Like the last time anything actually did happen is when was the transition from x86 to x64. The transition from 32-bit processors to 64-bit processors, that was real, and that happened very, very quickly.
Yeah, I remember. I had to upgrade Windows 7 to Windows XP to Windows 7 because of that reason.
Hmm. Yeah,
No,
so
it's not
like
good.
that was real,
Well,
but everything since then has just been nonsense that never materialized.
I haven't tried a Windows computer with an ARM processor, so I can't tell you that experience. But I mean, my MacBook is running an ARM processor, and I don't notice the difference because the emulation is really good. So it may be something you don't have to worry about because maybe the emulation will be just transparent. So you never know.
Yeah, and I remember there was also talk about 128 bits coming out, but it disappeared
About
completely.
what coming out?
128 bit GPUs,
Oh,
and that was a long time ago.
I never heard that. That would be cool. I don't know what for, but
Yeah, I think same
yeah,
question. Why do we have 8K displays or 4K displays? I mean, the human eye can't see the difference, and
I have a
makes only
4K
sense in
display, and it's overkill. I think 1440 is probably the sweet spot. So Half-Life 2 RTX looks really nice when standing still. It looks like nice. Yeah, it makes good. It makes good static. It makes good images when the scene is static, but it's not. It's not like a real time renderer. Really, it's a fake. It's fake real time.
Yeah, and real gamers, like a pro gamers who play for money, they actually switch down to a certain preferred resolution, like something very low, like 1440 by 960 or something.
And Valve has a some emulate something that runs like x64 executables on ARM. So they're doing a ton of work with emulation or whatever. However, they're doing it.
No, that's what I'm saying. Like, it may be something you don't have to worry about, like 32-bit support. You just let the emulation take care of it. So.
Yeah, I'm just more. I don't know. I feel more interested in solving like real issues
The
and
problem now.
making real products. Like those things are way more interesting to me than some theoretical thing that might could possibly happen in the future, but almost certainly won't.
I saw you fixed my bug report about uh, solid geometry. I made some demo where I wanted to carve out something and it crashed. Then you fixed something and you said it's very complex to carve out from the inside of an object something.
Well, I mean,
Now,
wasn't
look
wasn't it
also,
like a cone being carved out of a
yeah, yeah,
box? Yeah, out of a
yeah.
box.
I think
Yeah, I mean
cone was
that's
a bit challenging. Yeah,
that's never going to be great. Like all CSG mappers will have
I
some
was just
problems with that.
thinking that how the editor does it now. It just basically carves out something and doesn't really care about optimizations. But could it be like apply some post optimization to the amount of vertices created, like tessellation stuff?
Like to reduce the number of vertices.
Yeah, yeah.
That would be
There are some
difficult
algorithms out there.
because like the rules of I mean the reason the carve operation works is because the objects are assumed to be convex. So when you have like when you're carving a fairly complex shape out of another shape, you're making the result is going to be the only way it can make the resulting concave shape is by splitting it into a bunch of convex shapes. And the way it actually works is it goes through all the planes of the carving object and it splits every other object that it's intersecting in half by those planes and deletes one of those results, the result on one side. And that's how you make. And then if you go through that, then you can carve any shape out of any other shape. But it kind of breaks
Okay,
down. Like it doesn't work very well if you have really complex shapes.
but can we? Why can't we go the other way around? Like something like a fuse or join. You have two objects which are convex, and
Uh,
then join them become con
concave.
concave. Yeah.
Well, then then they would no longer be. They would no longer follow the rules of brushes, and so all the math that I use for those would no longer work. So like one trick with brushes is if they're convex, and you know there's a plane for each face, and each plane has a plane equation, then by definition, if you have a point in space, if it's behind all of those planes, which we have a an equation for a plane that tells you like the distance whether a point is in front
Yeah.
of or behind a plane. So if that point is behind all of the planes, then by definition that point is inside the brush.
Okay, but I don't. Okay, But in theory, if you don't join them and you have two concave objects just next to each other, it should behave the same in a lightning and physics sense.
Yeah.
But for example, I have the problem. I try to join two objects with physics also, not by solid geometry, but I didn't find really solid physics joints which could actually keep them together. They were just like a rubber or something.
Well, you can have physics shapes that are made out of multiple subobjects. You can have compound physics shapes. And the easiest you can either use the there's a tool in the editor that will calculate a it does a good job. I forget what it's called. It's under tools in the model editor. It's called convex decomposition, and what it does is it takes any mesh and it creates a series of convex holes that fit that mesh pretty closely. And it's not perfect, but it's pretty good. It's good enough for video game physics.
Okay, I didn't know that.
Yeah, it's a really great. It's like sometimes you really need that tool. It's a really yeah. It's under tools and then convex decomposition.
It's actually not that rare that you need it. I mean, if you make real games where you have to, where the player can craft some objects, it's actually very useful.
Yeah. So, yeah, that's what I've found so far. It's interesting to revisit some of this stuff, now that we have been able to use the engine in a little bit more. Um, it's interesting to revisit this and see, okay, can we make this better, according to, how we're actually using the engine now. So no, yeah, I don't have any and this is all development talk, so I don't have any definite for sure answers right now, but those are my results so far. I just started this Thursday, and I think it's pretty interesting. So I'll keep you guys updated as I learn more and as I experiment more and tune 5.1 to do the things that we want to do. Thank you all for joining. I will see you on the forum, on Discord, and on YouTube. Have a good day. And always remember, keep developing.